Hello viewers, Electric Circuits question 4, and it's very similar to question 3. The only exception is that we have added an extra 10 ohm resistor in parallel. So we've now got 3 10 ohm resistors in parallel, which means any electron is going to go through either top one, the middle one, or the bottom one. They're going to follow, an electron will follow one of those 3 paths. So we need to find, firstly, the total resistance. So our total is going to be 10 to the power of negative 1 plus 10 to the negative 1 plus 10 to the negative 1, whole thing to the power of negative 1. And we will get 10 over 3, which is 3.33 ohms. Or we could do it the fraction way that you saw in question 3, 1 over RT equals 1 over 10 plus 1 over 10 plus 1 over 10. Simplify and solve for RT. So we have the total resistance. Now let's get the current through the battery. So that means the common current, which is going to be the part of the loop that all 3 paths have in common. So it's going to be from this point around to that point. Okay, so we need to work out what the common current is. So ICOM is going to be V divided by R, which is V is 24, and the R we're using here is the total resistance, which is 3.33, and if we calculate that, we get 7.2 amps. So let's look at the current through each 10 ohm resistor. So for each 10 ohm resistor, I is going to be V, which is, for each of them, the voltage across each resistor is the same as the battery voltage because we're dealing with a purely parallel circuit. So that's 24 divided by 10, which gives you 2.4 amps. So we're expecting the currents through each resistor to add up to 7.2 amps here. So 7.2 amps through this part, and here we will get 2.4 through the first resistor, 2.4 going through the second resistor, so that'll be 4.8 going through this part of the wire. So at this junction, it's going to split into 2.4 that way, 4.8 that way. We've got 4.8 coming through here, splits into 2.4 going this way, 2.4 going through the bottom resistor, and these 2 paths meet up at this junction, so we'll have 4.8 through that part, which meets up with this 2.4 to get you 7.2 back going through the common part of the circuit. So we've got the current through each battery. Now let's work it and through each resistor. Let's therefore find the power output of the battery. So the power of the battery is I times V, which is through the battery it's 7.2 multiplied by the voltage is 24, and if we calculate that we get 172.4. 0.8 watts. Okay, so that's the battery power. Now let's get the power consumed by each resistor. So power of each resistor is I times V, which is 2.4 times 24, giving you 57.6 watts. So the battery puts out 172.8 watts, but each resistor uses up 57.6, and 57.6 times 3 is indeed 172.8. So everything works out as it should do there for the power. Thanks for watching. Over and out.